Okay, so what I'll do in this video is I'll just run through a couple of examples to do with trigonometry. I'll tell you the step-by-step process that I would go through to solve any kind of trigonometric problem like the one that is shown here. Okay, so your first step is always to label your sides. Okay, so what I mean by label sides is we've got our angle here. This one is opposite that angle, so that would be our O, that would be our opposite. We need to know what sides we're working with, and this one is the adjacent. Okay, that one's next to the angle, so that would be my adjacent, and this one is always the hypotenuse, but I don't know the hypotenuse either. I'm not actually having it to work it out. So the second step here is I would go so ka toa. Okay, and that is kind of what I would use. So from there I go, well, what have I got and what I'm trying to work out? So I've got the adjacent. So what I'm going to do is I'm going to tick I've got the adjacent, okay, and both the cos ratio and the tan ratio have the adjacent there. Okay, the next one is, I'm trying to work out the opposite. So that's a no, and that's a no. Okay, so now I can figure out which ratio I need to use. So I don't have a hypotenuse, so I'm not going to use the sine ratio. I've got the adjacent, but I don't have a hypotenuse, so I can't use that one. So tan has a tick on the opposite, a tick on the adjacent, so that's the ratio I need to use. So the third step is I would then write out that tan ratio. And that is tan of my angle is equal to the opposite over adjacent. Okay, so that is my ratio. That's a ratio that I'm going to be using for this one. Okay, so after I've got that, what I'll then do is I can then plug in the information that I've got, and that is step number 4. Okay, so step number 4, I've got tan, my angle here is 35 degrees. So tan 35 equals my opposite, now I don't know my opposite, x over the adjacent, which is 12. Okay, and we have a little sum that looks like this. Now, to find these ones, okay, what I would do is I need to multiply both sides by 12 to get whatever is up the top. So if I multiply this side by 12, that gets it from the bottom, takes a fraction from the bottom, I need to times this side by 12 as well. Whatever I do to that side, I have to do to this side. And that gives me 12 times tan 35 is equal to x, and then all you have to do is pipe that in to a calculator. So what I'll have is I'll do 12 times tan 35, and you can see your trigonometric buttons literally just here, sine, cos and tan. So 12 times tan 35, and I get 8.402. And 8.402 centimeters. And that's exactly how you would do an example like that. Now I'll show you again a slightly different example this time. And what I'll do is I will move the board up and give you another one. So let's say we have an angle of 40 degrees here, and we have this being 12 centimeters here, but I'm trying to find out the hypotenuse. Okay, so let's draw a line underneath that. So that is now the situation I've got where I'm trying to work out that. Again, the first thing I would always do is I'd label the sides. So step number 1 label the sides. Okay, so this one, always the hypotenuse. This one is the opposite the angle. And this one next to would be the adjacent. So from my first example, the second step up here was to find out which ratio we need to use. So step number 2. You go SOHCAHTOA again. So this time, what I've got my opposite. So I take the A's. But here, I don't have my adjacent at all. I'm trying to work out the hypotenuse. So I tick for the H and tick for the H. And it comes pretty clear that I'm not going to be using these two. I've got two values, the adjacent and the adjacent here, that I don't know, I can't use. So this is the one I'm going to have to use. Can't use that one, can't use that one. That's what I'm going to use. So, third step, sine of my angle is equal to my opposite over my hypotenuse. Okay, now, fourth step here, like before, that you can kind of see just at the top, is I put in what I knew. So here, if I put in what I know, sine of my angle, 40, equals opposite over hypotenuse. So my opposite is 12, so I get 12 over x. Now it's a tiny bit trickier, this one. We can't do what we did before and just times both sides by 12. Here you have to kind of do a bit of rearranging, and the way that you would rearrange this is your x is equal to 12 over sine 40. So when the length you're trying to work out is at the bottom, you have to rearrange it so it's 12 over sine of the angle. Okay, and then from there you would just type it into the calculator again. So what I'll do is 12 divided by sine 40, and here I get 18.668, which I'm going to round to 18.669, but I'm just rounding it to 3 decimal places just because I can. So this top one is an example of what to do when the x is on the top. That's just using the tan ratio, but it'd be the same for all the other ratios, sine, cos, or tan, if what you're trying to find is at the top. Whereas this one down here is what you can do with the x kind of appears on the bottom. Okay, any kind of basic trigonometric problem is either going to look like number 1 or number 2. Sometimes you might have to draw the triangle from something specific, like a diagram or whatever, but it will fall into one of these two categories if you were trying to calculate a length. Okay, let me know if you need anything else. Hopefully this helps.